Hello again, everyone. So now we have a talk about supporting complex camera stacks by Ricardo.
Thank you very much. Hi, everyone. Thank you so much. It's amazing. I've been using Debian since Potato. That's like a long time ago. And I think Debian played a great role on what I do professionally. And so I love you guys. It's a great honor to be here. Thank you. So, complex cameras. What's a complex camera and how can we support it? But first we need to define what is a complex camera. And I think the best way to define what is a complex camera is if we go from what is not a complex camera and then we finally define what is a complex camera and why we cannot use them today. So I'm going to go back 20 years in time again. And yeah, so standalone cameras. This is when we think of a USB camera, when we think a camera, a webcam, this is the kind of camera that we have, right? This has been supported in Linux since 2002 using an API called Video for Linux 2. And yeah, it's a great API, still in use today, and it not only supports cameras, but it was also used to support tuners, TV tuners. So if you wanted to watch not legal TV, if you wanted to decode legal TV, it was great. You could use some nice tools, and you could watch football without your parents having to pay for that. And yeah, so what does it mean that it's in Linux, right? It means that we have a device node that identifies the camera, and if this is just a file, we could just read from it. Yeah, I mean, some devices you can do that, but this is not supported in most of them, and you don't want to do this. There's plenty of reasons. There's a lot of memory copies if you want to do that. It's not performing really good, and also you want to decide how the frames look, and you cannot just do that. A typical Video for Linux program looks like this. It's a lot of code, but it's pretty simple. You open the device, open, it's just a file. You set the format. You say how big is the frame that you want to look into it. You set the params. That's how fast you want frames. I want frames at 20 frames per second, 30 frames per second. You configure it. You say, I want this amount of light, this white balance, all those parameters. You allocate some buffers. Say, I want these video frames to be in these 3 locations in memory. You give these frames to the kernel. You say, yeah, these are the frames. This is how I want them. And you start the camera. The moment you start camera, you call the queue buffer. And this system call is going to return when there's a frame ready for you. You use the image. That means you show it in the screen or whatever you want to do with it. And when you are done with the frame, you give it back to the kernel, so the kernel can put something else there. But yeah, I mean, this API is pretty simple, but the kernel shouldn't do much with the frames. Kernels shouldn't do video conversion because it takes a lot of time, and you want to do it. You don't want that to be done in the kernel. So this means that you need to support the video format supported by your camera. And yeah, I mean, the list is not small. Actually, the list is huge. So what do? You have a very big problem. If the best case scenario, you have some camera which supports some frames, and you have an application that needs specific frames. If it looks like this, like your camera supports more frames than the frames that you need, frame types that you need, then everybody is good. Everything is good. But what happens in this scenario? In this scenario means you cannot use your application is not going to work. It's pretty much so. If you are as old as me, you remember these kind of things. Like back in the days, if you wanted to play SimCity in MS-DOS, MS-DOS supported all the different sound cards with all the different formats. And if SimCity didn't support your audio card, you cannot use it. And it's pretty much what happens in Video for Linux. You need to rely on some libraries. The first library, or the most basic one, is called libv4l2. libv4l2 is doing some conversions. So it supports, I think, 3 or 4 video formats. And if your camera doesn't support one of these 3 or 4 video formats, it will convert those frames into your required format, right? And thanks to that, you only need to support these 3 formats or a subset of them, and then you're good to go. One of the applications using this library is QB4L2. This is the canonical application for testing Video for Linux. And yeah, it works well, but usually you want to do something with the frames. You don't just want to give them in memory. You want to do something else. You want to stream it. You want to show it in your screen a very fast frame rates. And this is where GStreamer is really good. GStreamer is I guess all of you know, it's a multimedia framework. You have different plugins, and you can connect between different inputs and outputs, and it's great. So that's it. Problem solved, right? It doesn't matter how the frames look like. It doesn't matter what are we doing to do with these frames. We just use Video for Linux and GStreamer, and yeah, we call it a day, right? That was easy. But no, it's not easy. Suddenly, hardware changed. So mobile phones started to become a thing, and this is an amazing piece of hardware. I guess you know it is the N800. MIMO's amazing. And yeah, it started to become complicated because now the video cameras are not just one modular device. In system on chips, we have different cores that vendors want to reuse, and they just connect one after each other. So it's not one static video device that you read from, it's a lot of sub-devices that you want to read from. So this is how Video for Linux works. You have a driver that supports video buffers, control framework, different helpers. So if you have, let's say, 100 different devices, that means you will need 100 different video drivers. And this doesn't scale because, yeah, we have thousands of different mobile phones. Instead, we invented something called Media Controller. Media Controller is it's a way that, so for every single core, now we have a different video device. So if we look at MIMO video API, a MIMO camera stack, each of these blocks is a different video device. So this is video 0, video 1, video 2, video 3, video 4, video 5. And then we have a new video device, which is the Media Controller, /Steph/Media 0, which allows you to connect all the different nodes and allows you to configure all this big mess of drivers. But now we have a problem, right? Because it's not that we cannot just simply use GStreamer, because GStreamer doesn't know how these video nodes are connected, how to connect, which to connect in which order. No, there should be some knowledge somewhere about how these video nodes. And then the other problem that we have is that with modular cameras, we realized that vendors, they were cheating to us all the time. Cameras are crap. I mean, everything is software. When you look at a frame, which you read directly from the sensor, this is what you get. You get something that is not useful. So you have this is a typical test pattern that we use to validate a camera. And actually this frame is for a really good sensor. And it's useless. It's noisy, color is completely out of balance. You cannot use it. Vendors have been cheating us all this time. They are using software to make this look into this. And of course they don't want to release it. I mean, this is the intellectual property, and going from this to this is how they make their bread and butter. This is how they make money. How this looks in how we support this kind of cameras in Linux today? Well, we have two approaches. The most open and nicer one is the one on the left. We have a new library which is called libcamera. Libcamera knows about the different components and how to connect it. It's called the pipeline handler. So for every family of devices, it knows how to connect it. It's doing a lot of heuristics, saying, yeah, this is how you, for this device, this is how you detect them, this is how you connect it, in which order you need to connect it, enable it. It provides an API, a stable API to that. So this is the libcamera public API. It also provides some connectors from this API to other connectors. So it can emulate a BD4 Linux device. It can emulate like if it was a standard camera like one before. It supports Pipewire. It supports GStreamer. So this is a great project, but we still have to solve this secret sauce problem, right? We still need something that converts from this one to this one, and this is done in libcamera with. They have a sandbox where you can put a binary from vendors, which is going to do the calibration for the camera on the fly to make this camera look nice. They also have some alternative. They also try to make some alternatives implementations completely open for that. They're still not as good as the proprietary one, but they exist. If you want something that you can use on a product, unfortunately today, the only real option for most of the devices is going with the proprietary blob. And there's also the bad or the less good option, which is some vendors, they just give up. They give you a huge proprietary blob, and they give you a GStreamer connection, a GStreamer plugin, and this is how you use their cameras. And then this is the one on the right. In Google, we also have these two worlds. On the left, we have Chrome OS. This is the company, this is the project I'm working on, where API is pretty much this. We have a camera HAL, which is doing the different abstractions to the applications, and we also have some proprietary blob where we keep the secret sauce from vendors and we interconnect with it. But there's also the other option, which is Android, which is exactly the same as this one, right? We have Android specifies a user space API, and they don't want to know how they implement it. Okay, whatever. Whatever kernel you have to use, whatever drivers you have to use, I don't want to look at it. Just give me this user space API. And yeah, so we are good, right? We support modular cameras. We support the standalone cameras. Yeah, life is nice, life is easy, but no. Now we go into complex cameras. So again, vendors, they're cheating us. Again, the cameras, they say they look like this. They say there are modules, there are one module connected to each other, but they are not. And they usually look like this. Or some of the cameras. Yes, I also don't want to lie. So some of the cameras, they look like this. They pretend to be a set of modules one after each other, but in reality, it's their own computing system. It's a computer inside your computer where you have different processing blocks. You have the MA engine. You have a Scalar CPU where you can run things, and then they tell you how to use this hardware. And they also use very fancy words. They call super HDR, zero shutter lag. The more attributes they give, the fancier it is. Super ultra mega frames per second. And yeah. And this is not what BD4 Linux is designed to work with, right? The drivers the framework that we have today is for connecting blocks and configuring the blocks. The API that we have today is not for programming blocks. If you look at this is pretty much a GPU. You have something that you can program, you can run your own program there, and this is not how our API. Our API doesn't work like this, and this is bad. We also have a big problem. This is very important for vendors. When you go to buy a mobile phone, the number one deciding factor when you buy a phone is not how much memory it has, it's not how much CPU it has, it's not how big the screen it is, it's how good is the camera. So people are willing to spend $100 more for a better camera than for twice the CPU. And therefore, vendors, they are very closed around their hardware and how it works and how to configure it and how is the internals. Plus, there's patent trolls everywhere. Like everything is patented, and the companies are afraid of violating a patent because it's really almost impossible to know if you're violating a patent in this area. So we have an API that doesn't represent properly how the hardware looks like. Our proposal is that let's make an API which fits the current hardware. It's good for complex cameras. And the proposal is, it's not novel. We haven't invented the wheel. We are just copying what DRM people is doing. We want to put all the complexity instead of in the kernel. We want to move it to user space. So we want something like Mesa, where it's doing all the complicated stuff, and the kernel should be as simple as possible, and also it should be pretty specific for that hardware. We cannot have a common API for every single device because every device is different. Not all devices have this architecture. Some devices look like this, some devices will have 15 processing blocks. So let's keep the kernel representing the hardware and make the API at user space level. We don't want to replace Video for Linux. We just want to make an API that is good for hardware that is not good supported in Video for Linux. And we want to follow the DRM model, where the complexity is in user space, is not in kernel space. Openness. We want everything to be open, of course. If a driver wants their hardware to be supported by this new framework, they need to provide a complete open implementation. Maybe we will leave some space for the secret sauce, like they have today, because they are used to it. They already used to that, and trying to take that away from vendors is going to be very complicated. But we want a stack that is exactly as open as it is today. We just want to put places in different locations. Instead of being in the kernel, we want things to be in user space. And we don't want we also going to support, or we don't plan to block other stacks for the same kind of hardware. So if they have a very advanced feature, let's say automatic makeup, background removal, or if they want to replace their face with a cat, they can do that in their proprietary stack that most likely nobody in this room is going to use. That will be probably just in mobile phones. I don't expect people using that in standard distros. So challenges. So again, the world is perfect, right? We have a way to support complex cameras. Everything is good. Yay! No, challenges. First of all, when we came to the Video for Linux community, they didn't like it. They didn't like it very much. For them, they want everything to be completely open. They want an API. They want the same API for every single hardware, and they don't want that vendors can access their hardware in with different APIs. So today, Video for Linux is it's built around the idea that we can always compete with vendors if we have enough time. We will have enough documentation to have a software which is as good as the vendors can provide. But from my point of view, I think for me it's fine if vendors use a specific block, has undocumented access to some blocks that are not needed for a standard usage of the camera. The only thing I care is that I can use my camera for video conferencing and for taking photos. I don't care if the camera also supports removing my face with a cat. I don't need support for that. And what happens? The cameras still need to be sold, right? Products, they need to be sold. And vendors, what are the way they are reacting to this is by putting software in the cameras. They are putting more and more software in cameras that emulates the API Video for Linux ones. And the problem of that is, remember, this is a device which has memory access. This is a device which has software that we don't control. And this is software that is made by vendors without any scrutiny. So I'd rather have this software where I can see it, where I can review it, because it has memory access than by vendors. But vendors, they are doing this. Yeah, and there's not much we can do. And the other thing vendors do is they just ignore us. Try to use, if we were looking into, yesterday we were talking about mobile phones using running Debian. I'm not aware of any one of those that works, the camera works. And that's a use case that most of the people have with their phones, right? You want to take photos of your kids or whatever. You want to be able to use your mobile phone, the features that you paid for. And also, more and more complex cameras are entering the notebook market. And what happens when people have notebooks where they cannot run Debian on it because the cameras cannot be used? Today, we cannot just ignore video conferencing. People are working remotely, and I spend more time. My manager is 10,000 kilometers from me. It only works because I can do video conferencing. And yeah, we can tell them to buy a USB camera, but again, it's hardware they have paid for. We are limiting the amount of. I want a Debian that supports as much hardware as possible. So, proposal. This is how we want. This is the final goal. This is how we want everything to look like. We want KCAM, or ISP as we call it now, supported in the kernel. We want lib camera to support ISP. And then we want all the applications be able to use the cameras through that stack. And that's the end goal, right? But we have a chicken and egg problem. On one side, vendors, they don't want to invest in a new framework if they don't have any warranty from the community that this is going to land. And then the upstream community, they don't trust vendors. They say, yeah, maybe if we give you something like KCAM, you are going to give everything proprietary, and then it's game over for everyone. So community, they want a fully implemented solution before they give their okay. And while this happens, users, they cannot use their hardware. It's a horrible solution. So we want somehow to unblock this situation. We want to give the opportunity to people to start using their hardware using ISP, KCAM. So what I want to try? So I want to make some Debian packages for the kernel component. All the code is completely open. It's a GPL license, GPL 2 license. It's kernel code. It's been developed in the open. You can follow the project. Source code and documentation is there. So I expect this shouldn't be an issue. The issue is the next level, is the camera framework, is what sits on top of the kernel. So right now we have two alternatives. One is implementing something lib camera, but again, this is not going to land in lib camera soon, or maybe it doesn't land. So how do we do it? We have an experimental package replacing lib camera. We have an experimental fork of lib camera. I really have no. We can try different things. Also, the problem is that today this code doesn't exist yet. We need to work on it. What we have today is some vendor code, which is open, which has some components that are proprietary, but most of it is open, and we can work with the vendor to try to make everything as open as possible. But I really want to, so again, my goal is to have something based on lib camera or something that is more open and more generic than vendor code. And yeah, for any of the two alternatives, as we have today in lib camera, there has to be two types of licenses. One which is open, which is the most of the code, And then we also need some proprietary code, some non-free code, which is going to keep the secret sauce. Hopefully, there's going to be also implementations in the open for secret sauce. What is the secret sauce, by the way? It's basically AAA, auto exposure, auto gain, auto focus. And yeah, today, I mean, this is nothing new. This closed license for AAA is something that happens also today in Blip Camera in our current situation. So yeah, how this looks from a Google point of view, it's pretty much the same. We will likely encapsulate Blip Camera inside a hull. So yeah, great. We can benefit from this solution. We won't want to reinvent the wheel. Android, yeah, they can still use the video for Linux and ISP drivers, but this will most likely be proprietary. I don't see this being open anytime soon. Maybe there's some vendors that will embrace a complete open solution, but this is going to be a very difficult selling point. The good thing is that if vendors they want to have their phone running Android, they will have to propose. They will have to have a complete open implementation. They have to give us also a complete open implementation. So we give them something in exchange. We get a camera that can be used for video conferencing, and they get an easier way for upgrading their phones in the future. Because upgrading the kernel is the most complicated part when they are upgrading Android. And I went pretty fast, but I also have some internals of how Kcam works. And if you have some questions, or if you don't have questions, I go to the internals, and this is horrible. So it's up to you. Yeah, it's two sides. And yeah, it's not only me doing this work. It's my whole team which is working on this. And yeah, I'm just the one which is closest to Cambridge.
Are the cameras mounted on the carpet bike?
Sorry?
Are there cameras mounted on the carpet bike?
I don't think so. Maybe I know the office is full of cameras, but yeah. Mike, please.
So, do you have any hardware vendors who are interested and might be convinced to help?
Yeah, so we have one vendor which is if we look at vendors that are mainly focused in Android, they are going to be the ones more difficult to sell because unfortunately the non-Android Linux for them represents 0.1% of the revenue and they are not willing to spend as much engineering in that 0.1% of their market compared to the other ones. But luckily there are vendors which they are heavily loaded in x86 and they are more likely to use it. If you look at that proposal, the code that implements IPU6, which is it's an Intel platform. And Intel makes sense, right? Intel is not too much into phones. It's more into hardware, into mobile phones, into notebooks.
So if you go back a couple of slides, you were showing, here, the comparison between Chrome OS and Android. Why is it so different between Chrome OS and Android? Why does it have to be Dragons for Android?
I think one of the reasons it has to be Dragons is that today the features that Android needs, the features that users are used to, they cannot be implemented with Video for Linux. So today you have phones which has 3-4 cameras. You go smoothly from one to the other. You don't know which one of your 3 cameras are using. You start to zoom in and suddenly you switch from one to the other. Ultra low noise, frames that are not squared, frames that are specific metadata. They need ways to hide their IP, and that is not supported in Video for Linux. So therefore they have to implement something. And also Android, they come into the conclusion that they can only enforce a user space API. There's no way you can enforce a kernel API for hardware which is completely different. And yeah, the PDF Linux doesn't support it, so they need to come in. They couldn't wait 20 years for implementing a solution that will work for them, and it will be upstream. That's the market pressure.
Okay, I have a follow-up question. You were mentioning that there needs to be a way to have, to hide the secret source somehow.
Mm-hmm.
But you were also mentioning that Google can just tell the vendor, if you want Android support, then just give us the open source stuff. Why cannot you do that for the secret source, though?
That's a very good question. So today they can have their secret source, and it's considered open. So once you give them that to vendors, giving it away from them, it is very complicated. The other thing is that there's a lot of patents around the secret source. And for doing specific things, there's only specific ways of doing it. And companies are very afraid of violating patents or other companies without knowing it. There's patent trolls. They just buy patents, and they try to wait for vendors to screw up and sue them. It's more easy to not being sued if you don't tell what you are doing. No, so AAA, I mean, it's nothing super fancy, but it's there. Yeah. So unfortunately, that's the situation. I wish we had something like in GPUs, where they make the gentleman agreement that, hey, we are not going to sue each other. Let's have a patent pool. We're going to put every patent in this pool, and we are going to respect each other and don't sue us. That hasn't been the case for video for cameras. And also that there is no need, right? Because we have no alternative in the kernel today for support this hardware. So why would we don't exist. That's the problem. We want to fix that. And one of the reasons to be here today is like, how if we were to land this in Debian, so Debian users can use their complex cameras, who will be if the license is fine, if the license is fine, and we follow the Debian principles, we want to know what will be the main risks that I'm going to face if I embrace into this project. So it will be nice to know from Debian if there is something obvious that this is wrong and this is bad. And for example, like Video for Linux community, they were quite clear that this is not the path that they want to follow. So something like that, even though it was bad news, it was great to have the bad news as fast as possible.
I'm not sure I can partially answer that question. So you made it quite clear that a complex camera is something that is highly specific, and making good use of it often influences the user interface to that camera. You mentioned zooming or other things. So if a vendor were to be forced to have an open source driver that will be probably specific to a specific development board, and if you try to use that camera in a different board, maybe even with slightly different clock timings, you wouldn't be able to use it anymore, or they wouldn't be telling you the setup sequences for your camera and you can't enable like HDR or whatever. And I fear that trying to do generic open drivers is something that falls short of the capabilities of these cameras and what users expect from them. So in effect, we'd get open source drivers, but they would be vastly inferior to the proprietary secret source. And that wouldn't feel like, oh, we have an open source driver, we can use them. It would be kind of something like a crippled camera, like running an AMD GPU without the firmware on it. That's a risk that I see here. Do you understand that?
Yeah. So for that, there's two ways to approach it. One is if we have a user space application, like if we have a user space framework like Lib Camera, if you support Lib Camera, that means your camera is good enough. Your camera is open enough, right? Because it's exposing the right API to users. It's the same as Mesa. If your driver supports Mesa, then your driver is open enough. That's one way to see it. The way I will prefer to see it is with features. It's like, this camera is good enough for doing video conferencing. This camera is good enough for taking static photos. Those, for me, those are the two use cases I mainly care of. Other use cases, for me, it's fine if vendors controls it. If you need the vendor stack to use different use cases, for me that's open enough, because that will give us enough use to the cameras.
If I may add to the Mesa part, I mean, for the typical GPUs as AMD or Intel, it's usually you supply the firmware and the GPU works almost everywhere, kinda, even on unsupported originally configurations. But for some modern GPUs, you're dependent on very specific firmware, which even if you have open source driver, without the vendor giving you the right firmware for your right combination, you cannot use the GPU really. So that's probably a valid concern here. We may end up with open source drivers, but if you don't get firmware for your specific connection and for your specific combination, you may end up with open source driver where, like, until you reverse engineer firmware or write your firmware, you're lost. And the firmware is pretty huge part for modern GPUs and probably these DSP operated cameras or like multi-blocks cameras.
So, yeah, we also want a framework as simple as possible. That's something we are pushing. We want to move all the complexity to user space. So if the framework, in my opinion, should only do scheduling. The things that are time critical, that should be done in framework, because you cannot do it in the CPU. You are a different time zone, to put it that way, and you cannot do it. Everything else should be done in hopefully in user space. But yeah, how to enforce it? It's complicated. But if at least the products that are in the market, you have a decent framework that you can use. If you can support the devices that are on the market, that's already much better than today, where you cannot support anything at all.
If I may one thing, this would be appealing, for example, for me a bit, if there would be, by default, you would get at least some like open source firmwares which are very, like, let's say, poor quality if you compare to proprietary ones, but you can have some assurance that if you get the hardware, you maybe get very low quality, but you will get functioning product with some open source setup at some point. And you may choose to use the proprietary firmware or blocks to get like to full quality of it.
I would love to have open framework, but I don't think that is something that when we have been trying to talk with vendors, they are completely no way. That's today, at least the vendors we have been talking with, we have not been lucky with that, and it will be complicated because you have. So it's not only the firmware they have to release; they also have to release the toolchain. They also have to. It's complicated. Yeah, and it's real-time hardware. It's yeah. Even for a mouse, trying to get the firmware from a vendor, it's complicated. I think you had a. Okay, so thank you very much.